Sets are fundamental objects in mathematics. Intuitively, a set is merely a collection of elements or members. There are various conventions for textually denoting sets. In any particular situation, an author typically chooses from among these conventions depending on which properties of the set are most relevant to the immediate context or on which perspective is most useful. Denoting a set as an object, where it is desirable to refer to a set as an indivisible entity, one typically denotes it by a single capital letter. In referring to an arbitrary, generic set, a typical notational choice is S. When several sets are being discussed simultaneously, they are often denoted by the first few capitals, A, B, C, and so forth. By convention, particular symbols are reserved for the most important sets of numbers, empty set, integers, natural numbers, rational numbers, real numbers, complex numbers. Some authors use the Blackboard bold font for these particular sets. This usage is widely accepted in handwriting, but many mathematicians, and such experts on mathematical typography as Donald Knuth, advise against its use in print. Focusing on the membership of a set, in many contexts one is interested more in the elements that constitute the set than in the single entity comprising those elements, for instance where stating an extensional definition of the set. Here the elements, whether expressed discretely or in some aggregate manner, are enclosed in braces. The simplest notational approach of this type, which is feasible only for fairly small sets, is to enumerate the elements exhaustively. Thus the set of suits in a standard deck of playing cards is denoted by an unregistered trademark, an unregistered trademark, an unregistered trademark yen, an unregistered trademark pound, and the set of even prime numbers is denoted by 2. This approach also provides the notation for the empty set. The semantics of the term set imposes certain syntactic constraints on these notations. The only information that is fundamental for a set is which particular objects are, or are not, elements. As a result, the order in which elements appear in an enumeration is irrelevant. I 6, 1/2 and 1/2, I 6 are two enumerations of a single set. Likewise, repeated mention of an element is also irrelevant, so 1, 2, 2, 3, 3, 3 equals 1, 2, 3. To deal with collections for which members' multiplicity is significant, there is a generalization of sets called multisets. A variant of this explicitly exhaustive enumeration uses ranges of elements and features the ellipsis. Thus the set of the first 10 natural numbers is 1, 2, 3, 10. Here, of course, the ellipsis means, and so forth. Note that wherever an ellipsis is used to denote a range, it is punctuated as though it were an element of the set. If either extreme of a range is indeterminate, it may be denoted by a mathematical expression giving a formula to compute it. As an example, if n is known from context to be a positive integer, then the set of the first n perfect squares may be denoted by 1. n2. Some infinite sets too, can be represented in this way. An example is denoting the set of natural numbers by 1, 2, 3. In cases where the infinitely repeating pattern is not obvious, one can insert an expression to represent a generic element of the set, as with 0, 1, 3. K1 closing round bracket over 2. A more powerful mechanism for denoting a set in terms of its elements is set builder notation. Here the general pattern is X, P, X, which denotes the set of all elements X for which the assertion P, X, about X is true. For example, when understood as a set of points, the circle with radius at and center, may be denoted as, U, V, 2 plus 2 equals R2. A notable exception to the braces notation is used to express intervals on the real line. Any such interval is well defined only because the real numbers are totally ordered. It is completely determined by its left and right endpoints. The unit interval, for instance, is the set of reals between 0 and 1. The convention for denoting intervals uses brackets and parentheses, depending as the corresponding endpoint is included in or excluded from the set, respectively. Thus the set of reals with absolute value less than 1 is denoted by a euro. Note that this is very different from the ordered pair with first entry a 1 and second entry 1. As other examples, the set of reals X that satisfy 2